Hi friends, how are you? Today we discuss 3D picture of heart. Every animal has heart. This is a 3D picture of heart. We should rotate this and show all around shape of our heart and its part. This is our heart surface below. Most below here is surface of heart and going up arterium right and it inferior vena cava. Now we discuss heart. The heart is a muscular organ in most animal which pumps blood through the blood vessel of the circulatory system. Blood provides the body with oxygen and nutrients as well as assisting in the removal of metabolic wastes. In human, the heart is located between the lungs in the middle compartment of the chest. Okay. In humans, other mammals, and birds, the heart is divided into four chambers: upper left and right arteria, and lower left and right ventricles. Commonly, the right arterium and ventricle are referred together as the right heart and their left counterpart as the left heart. Fish, in contrast, have two chamber arterium and a ventricles, while reptiles have three chambers. In a healthy heart, blood flow one way through the heart due to heart valves which prevent backflow. The heart is enclosed in a protective sac, the pericardium, which also contains a small amount of fluid. The wall of the heart is made up of three layers: epicardium, myocardium, and endocardium. The best The heart pumps blood with a rhythm determined by a group of pacemaking cells in the sinoatrial node. These generate a current that causes contraction of heart traveling through the atrioventricular node and along the conduction system of heart. The heart receives blood low in oxygen from the system circulation which enter the right arterium from the superior and inferior vena cava and passes to the right ventricle. From here it is pumped into the pulmonary circulation through the lungs where it receives oxygen and gives off carbon dioxide. Oxygenated blood then return to left atrium, passes through the left ventricle and is pumped out through the arota to the systemic circulation where the oxygen is used and metabolized to carbon dioxide. The heart beat at a resting rate close to 72 beats per minute. Exercise temporarily increased the rate but lower resting heart rate in the long term and is good for heart health. Now we discuss its parts. You show here clearly the most lower part, which is sky blue color. This is called surface of heart. This is the shape of surface of heart. You show clearly. Surface of heart. On its there is coronary arteries great cardiac vein, and all around it. Okay, the surface of heart. The heart has three surfaces: anterior, inferior, and posterior. These surfaces are known as sternocostal, anterior, diaphragmatic, inferior, and base, which is called posterior. Okay, now we discuss these type of veins which are on it. This sky blue color called great cardiac vein. These veins are all around the surface of heart. You show clearly here. These start from here and going around on to this vena cava, inferior vena cava, and then start from here and going to this here, and this is branches of it. It is also along issue here. Coronary arteries. It is along where is coronary arteries. There is great cardiac vein issue here. This is so. The great cardiac vein, also called left coronary vein, begins at the apex of the heart and ascends along the anterior longitudinal sulcus to the base of the ventricles. In the It then curves around the left margin of the heart to reach the posterior surface. It merges with the oblique vein of the left atrium to form the coronary sinus, which drain into the right atrium. At the junction of the great cardiac vein and the coronary sinus, there is typically a valve present. This is the Vicen's valve of the coronary sinus. It receives tributaries from the left atrium and from both ventricles. One of left marginal vein is of the considerable size and ascends along the left margin of the heart. Okay, now we discuss next this type of vein called coronary arteries, which is sky blue color. The coronary arteries we show, this is also a great cardiac vein types around the heart surface. Show clearly. These are this coronary arteries. The coronary arteries are the arteries of the coronary circulation which transport blood into and out of the cardiac muscle. They are mainly composed of the left and right coronary arteries, both of which give off branches. Okay. The left coronary artery rises from the arota above left cusp of the aortic valve and feeds blood to the left side. The heart, it branches into two arteries and sometimes a third branch is formed at the fork known as ramus or intermediate artery. The right artery originates from above the right cusp of the aortic valve. It travels down the right coronary sulcus toward the crux of heart. There is also conus artery which is only present in about 45% of the human population and which may provide collateral blood to flow to the heart when left artery descending artery is occluded. Okay. Now next part is this sky blue color. Here is show inferior vena cava. This is inferior vena cava. This is shape of inferior vena cava. It is joined to arterium right. Okay. Inferior vena cava. The inferior vena cava is a large vein that carries deoxygenated blood from lower and middle body into the right arterium of heart. It was at rigid and has valve, so the bulb does not flow down via gravity. It is formed by the joining of the right and the left coronal iliac vein, usually at the level of the left lumbar vertebra. The inferior vena cava is the lower of the two venae cavae. The two large vena cava that carry designated blood from the body. The inferior vena cava carries blood from the lower half of the body, whilst the superior vena cava carries blood from the upper half of the body. Okay. Now we discuss superior vena. The superior vena cava (SVC) is the superior of the two vena cava, the great venous trunks that return oxygenated blood from the systemic circulation to the right arterium of the heart. It is large diameter 24 mm, yet short vein that receive venous return from the upper half of the body above the diaphragm. Venous return from the lower half below the diaphragm flows through the inferior vena cava. The SVC located in the anterior right superior mediastinum. It is the typical site of central venous access. CVA via central venous chatter or a peripheral fairly inserted central catheter. Mention of the cava without further specification usually refer to the SVC. Okay. Now we discuss arterium right and arterium. This is arterium right. Show its shape. Around its shape, this is the arterium right is the upper chamber in which blood enters the heart. There are two arteria in the human heart which receive blood, the left arterium from the lungs and the right arterium from the venous circulation. The arteria receive blood, and when the heart muscle contract, pump blood to the ventricles. All animals with a closed circulatory system include at least one arterium or auricle. Humans have two arteria. The arterium used to be called the auricle, and that term is still used to describe this chamber in, for example, the mollusca, but in humans that name is now used for an appendage of the arterium. Okay. Now we discuss arterium left. This is arterium left. This is its shape. This is called arterium left. Arterium left. You show also vein on its. First we discuss arterium left. This is sky blue color. The arterium is the upper chamber in which blood enters the heart. There are two arteria in the human heart which receive blood. The left arterium from the lungs, arterium from the veins. We discussed before this. Venous circulation. The arteria receive blood, and when the heart contract pump blood to the ventricle. All animals with a closed circulatory system include at least one arterium. Auricle. Women have two arteria. We tell you before this. The arterium used to be called the auricle, and that term is still used to describe this chamber in, for example, the mollusca. But in human, that name is now used for an appendage, arterium. Okay, we discuss the veins on its left arteria. These. Also show you on its there is also some veins. These veins are called pulmonary veins. Show these are 4 in numbers. The pulmonary veins are the veins that transfer oxygenated blood from the lungs to the heart. The largest pulmonary veins are the 4 main pulmonary veins, 2 from each lung that drain into the left atrium of heart. The pulmonary veins are part of the pulmonary circulation. Structure. 2 main pulmonary veins emerge from each lung's ileum, receiving blood from 3 or 4 bronchial veins apices and draining into the left atrium. An anterior and superior main vein drains each lung, so there are 4 main veins in total. Okay, we discussed the chain on its these branches on the vein. Pulmonary veins, and these are pulmonary vein branches. All 4 pulmonary veins have this type of branches you show here rightly. This the pulmonary veins are the veins that transfer oxygenated blood from the lungs to the heart. The largest pulmonary veins are the 4 main pulmonary veins, 2 from each lungs that drain into the left atrium of the heart. The pulmonary veins are part of the pulmonary circulation. Structure we discussed just before is same. Now we discuss this part. What is called this part? This is the pulmonary artery. Shows this is the shape of pulmonary arteries. First we discuss pulmonary veins. Now we discuss pulmonary arteries. This is pulmonary arteries. The pulmonary artery is an artery in the pulmonary circulation that carry deoxygenated blood from the right side of the heart to the lungs. The largest pulmonary artery is the main pulmonary artery or pulmonary trunk from the heart, and the smallest one are the arteries which lead to the capillaries that surrounded the pulmonary alveoli. Its function. The pulmonary arteries carries deoxygenated blood from the right ventricle to the lungs. The blood here passes through capillaries adjacent to alveoli and become oxygenated as a process of the respiration. Okay. Now we discuss aortic arc. This is aortic arc. Just above aorta. We discuss just aorta first. This is aorta. The aorta is the main aorta, just sky blue color which term. This is called aorta. You show its shape. This is its shape. The aorta is the main artery in the human body, originated from the left ventricle of the heart. and extended down to the abdomen, where it split into two smaller arteries. The like arteries, the aorta distribute oxygenated blood to all parts of the body through the systemic circulation. And its function, the aorta supplies all of the systematic circulation, which means that the entire body except for the respiratory zone of the lungs receives its blood from the aorta. Broadly speaking, branches from the ascending aorta supply the heart, branches from the aortic arch supply the head, neck, and arms, branches from the thoracic descending aorta supply the chest, excluding the heart and the respiratory zone of the lungs, and branches from the abdominal aorta supply the abdomen, the pelvis, and legs. Get the blood from the common like arteries. Aortic arc. The aortic arc of the aorta or transverse aortic arc is the part of the aorta between the ascending and descending aorta. The aorta travel backwards so that it ultimately runs to the left of the trachea. Structure at the cellular. This shows your structure. Arc are composed of three levels. At the cellular level, the aorta and the aortic arc are composed of three layers. The tunica intima, which surrounds the lumen and is composed of simple squamous epithelial cell. The tunica media, composed of smooth cell, muscle, and elastic fiber, and the tunica dimentia, composed of loose collagen fiber innervated by barometric nerves. Terminal. The aortic arc is responsible for sensing changes in the dilation of the vascular walls, including changes in heart rate to compensate for changes in blood pressure. The aorta begins at the level of the upper border of the ascending sternocostal articulation of the right side and runs at first upward, backward, and to the left in front of the trachea, then travel backward on the left side of trachea, and finally passes down on the left side of the body of fourth thoracic vertebra. At this point, the aortic arc continues as descending aorta. The aortic arc has three branches. The first and largest branch of the arc of the aorta is the brachiocephalic trunk, which is to the right and slightly anterior to the other two branches and originate behind the manubrium of the sternum. Next, the left common carotid arteries originated from the aortic arc to the left of the brachiocephalic trunk, then ascend along the left side of the trachea and through the superior mediastinum. Finally, the left subclavian artery comes off the aortic arc to the left common aortic artery and ascend with the left common aorta through the superior mediastinum and along the left side of the trachea. An anatomical variation is that left vertebral artery can arise from the aortic arc instead of the left subclavian arteries. The arc of the aorta forms two curvatures, one with its convexity upward, the other with its convexity forward and to left, and its upper border is usually about 2.5 cm below the superior border to the manubrium, centering blood flow from the upper curvature to the upper region of the body located above the heart, namely the arms, neck, and head. Coming out of heart, the thoracic arota has a maximum diameter of 40 millimeter at the root. By the time it becomes the ascending aorta, the diameter should be 35 to 38 millimeter and 30 millimeter at the arc. The diameter of the descending aorta should not exceed 25 millimeter. The arc of the aorta lies within the mediastinum.